So, hello everyone. Thank you for the introduction, but once again, my name is Marcis Donerblics. I'm the vice lead of Engineering and Technical Operations Group at VIRAC, which means we're in charge of running radio telescopes, now newly added LOFAR station. This is my first time here, and first time starting to talk about LOFAR as well. So I will treat this more like an introduction and hopefully an open platform for further questions down the line. So a little outline of my presentation. I will give a brief background on VIRAC. I'm not sure if a lot of you know our station since we're very new in this community. I will list some steps taken towards LOFAR developing towards the station, show some nice pictures of actually building the station, discuss in brief our future expectations from the station, list some key takeaways, and if at all possible, I'll try to sneak in a small discussion of them at the end of this. So about the VIRAC. It stands for Ventspils International Radio Astronomy Center, which is a research institution affiliated with Ventspils University of Applied Sciences. So we're a subdivision of a university. Our institute has 6 main departments. Department of Astronomy and Astrophysics, Electronics and Satellite Technologies, our Engineering and Technical Operations Group, as well as Economics Research Group and the Remote Sensing Group, which all of these groups are also supported by another engineering group doing HPC calculations when needed. So a brief history. In the 50s, a secret Soviet base was established. Between 1960 and 70, 2 radio telescopes with 32-meter and 16-meter parabolic main reflectors were built. Nothing much is known from that time. No papers came out of this because, of course, they weren't used for science, even though Russians claim it was. In 1994, when it was fully left alone by the USSR military, our National Academy of Sciences took over. Didn't really know what to do. The telescopes were damaged heavily, and at some point decided to establish this new institute, VIRAC, and say, go play around with these telescopes. And that they did. In 1998, they managed to refurbish them to the point where actual movement was allowed once more. Forward from that, around 2004, this institute was merged with the university. In 2010, another institute was added, which basically established VIRAC as it is today. Coming into more modern times, between 2013 and 16, we did a major renovation of the telescopes. You can see some pictures during the process. Also, 2013-14 is the time when first ideas about LOFAR station for us start to emerge. 2015-16, linked to the finishing stages of renovation, we become a member of EVN, the European Very Long Baseline Interferometry Network. And from 2017 to 2019, so roughly a 3-year period, is the actual LOFAR project where we build and establish our own station. And now in 2019 we have 3 fully operational instruments, the RD32 and 16 classical radio telescopes, as well as the newly built LV614 station. just to see the type of work that we do, and this will be sort of, I hope, a visit card for us where we can apply our engineering knowledge. Is just the vast difference of things during renovation. So in 2011, the top left corner, that was our control room, still up to that time. Right below it, our graphical user interface for operating the telescope right now. On the top corner you can see systems providing power to drive the telescopes. On the left, the old system. On the right, few new cabinets. That's all you need. Also the difference between drive systems. Even though we have done a lot during the renovation, there are some still additional ideas and ideas to always improve, indicated by dynamically adjustable secondary reflectors and so on. I did mention that we have two telescopes, so the other one got a completely new carbon fiber structure dish. So that's maybe interesting for you to see. Yeah. Just the differences and how the VLBI equipment looks like during normal observations, our receivers, and the modern times. So our RT16 right now in comparison to the pictures previously. Our main instrument, the RT32. Additionally, just to branch out, we do contracts with the industry and try to do as much there as we can. This is a picture of one ground station, which is also a way maybe how you can here bring in some funds at some time, because they become needed. But now actually developing towards LOFAR. So as I mentioned previously, in 2013, 2014, the first ideas start to emerge. And I will be very straightforward. These came basically from our previous director, Mr. BALTICS, instead of the astronomer background, which is what I would expect to see, right? So maybe there is a learning thing here which you can take away that gets your astronomers behind new projects like establishing a LOFAR station before actually building one. It will help a lot, right? In 2016 and 2018, as Kamen mentioned, there was this BALTICS project running, so building on advanced LOFAR technology for innovation, collaboration, and sustainability, as the acronym is broadened out. So that was a good opportunity for our people to get up to speed and to learn about what LOFAR is and how to operate it. Again, timing may be good, maybe not so much, but that was a very needed part of this. So I'm very glad to hear that you have already looked towards a twinning project like this one. Yeah, and 2017 to 2019, building the station. A little bit about the BALTICS project. So the most important part, at least in my view, I have engineering background in electronics engineering. We had 4 training weeks provided by Astron in RF development and phased array digital signal processing. We had 6-month-long staff exchanges with Astron on various subjects like array processing, RF development, LOFAR station maintenance, and so on. Additionally, summer school on data processing, as well as the same approach with another partner, the Manchester University, which also provided 2 training weeks, 2 workshops, 2 staff exchanges. and some additional staff training and building things that we did. This was also my personal experience a little bit, because I did spend during this project about 2.5 months at Ostron doing exactly the training on LOFAR stations. So again, some pictures, some ideas of what we did. Maintenance at LOFAR stations. That actually means that we are following the Astron engineers and doing maintenance with them, which means now that we have our own station, we know where to look, we know what is what, and when we get some information, let's say, oh, go look at this one, or that thing is not working correctly, we know exactly where to look. We don't have to ask, what do you mean by this? And this is very important. So if at all possible, do this kind of training as well. We did start to attend ILT technical operation groups meetings just to see what's going on, get up to speed and get in the community. We did carry out RFI measurement surveys at different stations just to compare it with our own and know how to upkeep this RFI cleanliness on our own station. Another interesting keyword, HBA-PC. So that's already going more into details about the LOFAR. The LOFAR is split in LBA and HBA fields, as you may know. The HBA tile needs control, and of course it's implemented by the systems. However, when you need to do maintenance or test something, you don't really know how this operates. So this PC is basically a black box that can talk with the LOFAR tile, and we did develop this basically from scratch. So now we know at the very hardware level how to deal with our station. And when you know this, you can apply it to Astron backyard tiles, the test tiles that I have literally in the background somewhere, just to test if you can bring them up into operation and maybe repurpose them for satellite observations as we did, right? Additionally, just visiting the Westerbork observations, carrying out near-field interference source detection observations at the stations, just general pulling of knowledge. So how this looks in practice, we are just running around doing RFI measurements, receiving satellite images. This is the setup I talked about previously, how to control a tile. Doing the near-field imaging to detect the source of RFI. Also might come in handy, especially if you're in an area more littered with RFI. Or doing some AM station monitoring, which is also another RFI source for the station. But now more about the LOFAR project itself. Here I will try to list step by step, actually in chronological order, what we did to arrive at the station. I'm not saying that this is the approach that needs to be taken, but know that this is what we did and maybe try to improve on that. So the project starts in 2017. First of all, the station location is determined. We have a very unique case where we already had 40-hectare land for our telescope site. So it means that we will definitely put the station there. Okay, there needs to be a smaller subset place. We need to determine that, but we don't have to worry about RFI or leasing the land from farmers or whoever else. The second step is to show off the site to Astron and Astrotech people and actually do the agreements that this is fine. Of course, they will do on-site RFI measurements to verify that everything that we say is correct. Please do the same when you arrive at the station, just to double check that your ideas are correct. Right around this time, Latvia also starts to participate in ILT Director Board meetings as an observer, as was mentioned previously. This was mostly positive experience and another way how to get into the community. Then the actual project parts, topological and geological survey of the site, because even though in the picture you can see the site during construction, it wasn't that nice and flat before. It was a forest, just like behind it. And even more so, it was basically a swamp. So to convert that to something usable for a LOFAR station, it's first of all really expensive, but second of all very hard work. But it was done. Memorandum of understanding with Astrotech Holding was signed just to know that they will deliver the station. We had to do agreement with Latvian Forestry Agency for them to allow us to deforest the area and to use it for the station, which is also another thing where you could spend more time than needed, because a lot of people concerned about frogs and whatnot will definitely try to stop you. So allocate some time for this as well. I'm sure it's the same way here, but our university is government run, so it means all procurements, all things need to be through tendering systems. And it's not easy actually to prove to the government that, you know, Astrotech is the only one who can provide a LOFAR station. Even though it might seem otherwise. So paperwork takes up a lot of time. But it gets through, and after that you need to do contracts for developing projects for converting the actual ground to be suitable for a LOFAR station. Additionally, our project was a little bit bigger than just to build the station. We also wanted to establish some nice RF laboratories with them, so tendering agreements for that as well. 2018 rolls around, when we can actually start to do the construction and communication installation on the RF laboratory part, but not yet on the station site, which again takes a lot of time. Construction project is finalized, so only after there is the exact project exact step-by-step thing approved by council of building or something like that, only then you can move forward with actual construction work. Communication systems like electrical power, optical fiber, etc. are linked to the field at this point, and the field construction project is finalized and work on the field starts. Yeah, so the construction plans and overall progress from time to time is discussed face to face, either in Netherlands or in Latvia. Meantime, the deforestation of this area goes on. Tendering agreements again for actually doing the station construction. Now the hard part, after all of the paperwork, still LOFAR field construction contractors need to be found. So some people who can actually build the field, build the foundation for this. Again, not easy, and again through procurement systems. So allocate a lot of time for that. In our case, it actually didn't go through 1 or 2 times in a row, and only after that we could go and speak with people directly, because the first time around everyone just wanted way too much money, which is not feasible. And as it turns out, you can build even a very high-class field with a lot less than asked. Yeah, you have to contract also the control agency, which looks upon this construction work and says if everything's done correctly. Prepare the field, check if the station equipment is built, and then 2019 comes around. Finally we can do the LOFAR, well, finalize the field construction, deliver station equipment, build the station, do the grand opening ceremony, sign an ILT contract, and finalize the project documentation. So this was the very lengthy and hard time for us. However, it's only 3 years in comparison to what Peter mentioned. So maybe that's better, maybe not. I think a lot of things for us was rushed, but it is what it is, and we have the station now. Again, some nice pictures just to show you how this goes on. First of all, the idea about the place. Of course, it's our station site, more specifically that green area, which after deforestation looks like that. Do the RFI measurements, as I mentioned previously, and be very happy about what you see on the left-hand side. Just for the impact, more pictures of how the field looked before. And when the actual construction work begins, expect something like that. Right? Yeah, don't forget about the water drainage systems, because if that swamp gets more water, you will drown. And when you start to actually get somewhere with this, remember that communication is key. Because in our case, for some reason or another, most of the communication was done by management people, not necessarily being linked to the actual practical work. And this brings about a lot of issues which could be avoided if you brought in engineers all along. So please take this as a learning thing. But once we actually start to communicate, once we bring engineers and people from Astron and Astrotech together and check what's going on, progress goes way smoother. If you would like to see how actually we can construct some parts of LOFAR, I can provide this as well. So this is assembly of one tile. Yeah, not really. Even though everyone keeps telling us get students, say them that they will be able to do their PhDs with the LOFAR station, students are not readily available, and even more so during the summer. So a lot of the people there are on our own engineering team, and also contracted people, even high school students during the summer, but through contractors. But do pay attention to how many people are working just to streamline this process. And understand that one tile is not everything. We do have to assemble 96 of them. So I will cut this short, but just see the conveyor system which we used, and see that the parts are stacked on one side, the other side everything's linked with the code system. Everything has to go in the correct place to get the system running. Just so this is a smooth process, a lot of planning. Right. Yeah, well, the tent is just rented from a contractor, and the floor is put in place. You see the ESD protective mat and everything. And once all of that is done, be very happy about your station. You can see some finishing cheers and the signing process. I already saw some pictures from this. However, again, another thing to take away, don't think that at this point everything's finished, because it's not. It only means that yes, you can feel the technical requirements and you can operate the station now, but it doesn't mean that there aren't issues which still need to be dealt with, and as with every new system, till it's 100%, you will find issues and faults, and we'll constantly check them, upgrade things, and run. However, during this acceptance testing, you should be able to get some nice images like the Milky Way, which proves that our station's running. And that we are linking us as well. So, yeah, the ILT. This is here the last slide, because the last part also of what I mentioned previously was to sign the ILT contract. Acceptance before that, of course, now, and we have a newly built station, which looks something like this now. Regarding the future expectations, so one thing is that we want to be a part of the European and global radio astronomy community. We want to provide this opportunity for our university and the whole Latvia in general to participate in research done with this infrastructure. We want to carry out research in such fields as high energy cosmic radiation, pulsars, and sun activity, as well as cosmic magnetism. These are the topics listed just because we already have astronomers with background in this. We want to provide Latvian scientific community the opportunity to participate in world-class research and ability to write projects based on this. It was already mentioned in previous talks that well, you don't have this instrument where you're not a part of ILT and so on. You are not necessarily granted the projects, even though if the proposal is good. So hopefully this will help with that. And of course, also my own technical side, we want to develop new knowledge, know-how in the technical fields linked to big data, RF engineering, and so on, to help further improve the instruments. And the takeaways, key takeaways. So, first of all, one can successfully build a LOFAR station, even though if they don't know what they are doing, even though if they are new to this. It is possible, we have proven that. So, don't be afraid to build this if you feel that this instrument will bring some added value to your institution. However, know why you're building the station. Because as I mentioned previously, if that's the ambition to say that we have this, that we are a part of this and so on, it's all very good. But if it's not backed by the astronomer part, by the research part, which actually needs the instrument, it sort of makes no sense. And even if it does in future, there is a very steep learning curve, which we are fighting right now. So something to avoid. Always keep in mind why you're applying for this station to be built. Skilled technical staff is a necessity. As I mentioned previously, when you allow the management to organize the project and to plan things. One thing, everything is more expensive than it needs to be. The things that are good are overdone. The things that are not done, they are not done at all because they weren't foreseeing that. So always bring along technical staff, engineers to all of your talks, do the twinning projects, send them off to Astron to do the training, because they will tell you literally you need to do this or something else at any given time. Planning is king. So even when you have skilled technical staff, even when you know what you're doing, if things come in the wrong order, it's time consuming and expensive. So again, some places to learn from us. Yeah, keep up constant communication between management, astronomers, and technical staff. This just drives further my point that when you put these groups together, good things happen. When you try to isolate them or do something without consulting the other, you run into issues. Brush upon existing contacts and develop new ones. As I mentioned previously, you can build a station even if you don't know what you're doing, but you cannot do it without good contacts and people to guide you. So become the part of the community. Don't be afraid to contact people, ask for help and guidance. Us, VIRAC, included in this. I'm sure that our people will be more than happy to help. Of course, twinning projects and so on. Yeah, and even when everything is put on paper, even when the actual project is listed out, even though you know exactly what to do, don't rely on this paperwork. Actually think about what you're doing and adjust on need-to basis. Keep the constant communication. Don't rely on one thing that was decided 2 years ago, right? Or that you might have misunderstood. Just keep constant communication, even to week, day-to-day basis, if you want a swift result and efficient result. Okay, so this is in very brief my introduction on how we achieve this status when we have our own station. But maybe you have questions, maybe you would want me to elaborate on something. Please.